Hello, I welcome you all to this another interesting screencast, and the problem reads that the springs BA and BC each have a stiffness of 500 newtons per meter and an stretched length of 3 meters. Determine the horizontal force F applied to the cord which is attached to the small spring B to the small ring B so that the displacement of the ring from the wall is D equal to 1.5 meters. From the same figure, the springs BA and BC each have a stiffness of 500 newtons per meter and an stretched length of 3 meters. Determine the displacement D of the cord from the wall when a force F equal to 175 newton is applied to the cord. Both these problems are coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So one is just a reverse of the other. So we are just going to apply the equations of equilibrium about this particular point B here, and they've told us the length of the unstretched length, and they're asking us to find the force F in the first case. And you know that the spring force S is just equal to, which in our case is AB, which is also equal to BC, is just equal to K times S, K being the spring stiffness, S being the stretch, and the stretch in here is just L final minus L naught. So we have everything, we just plug these things, these plug values in there in those equations, and then we find what we want. And we do the reverse in the other case. Alright, so first things first, let's draw the free body diagram. Let's do a section. Imagine we cut it there, we cut the spring there, and then once we've done so, then we expect a force, spring force like so, like so, like so, like so, and like so. Okay, so this one is the force we are looking for, and then we have the spring force there like so. We have there like so, and then let's call this as let's call it as this is BA, okay, which is also here BA, and this one is BC, which is there like so. All right, and then the slope, this is equal to 1.5 meters. Okay, we've been given that, so we can be able to compute the slope. I will draw it just separately here because I don't have space there. So we have the slope, just drawing using a right angle triangle. I might prefer this, but we can also calculate the angle if you prefer angle. So this is 1.5, and then we have the run, because this mid length here is equal to this one here. This is equal to 3, just 3. Okay, all right, there we go. So 1.5, and then we have this one is 3 meters. This is 3 meters, so this is 3. So if we are to calculate that, finding the hypotenuse, 1.5 squared plus 3 squared, so this becomes root of 11.25, right? 1.5 squared plus 3 squared, 11.25, great. Okay, so now let's finalize. So we're going to have a component in this direction like so. We'll have another one like so. Then we'll have another one in this direction like so, and then another one like so. All right, let's label these. So this one is BA, BA times BA times the rise. This slope applies for both because this particular system is symmetrical, so you expect BA to be equal to BC. Okay, the system is symmetrical. Okay, so about this horizontal axis, symmetrical about this horizontal axis, right? So expect, because of symmetry, you expect BA to be equal to BC, which is just equal to Fs spring force. Okay, right. So even this slope is the same. If we are to redraw this, it's the same. We are just going to mirror it like so. We do the mirror like so, which is the same thing. So we have a 1.5, you have a 3, then you have root of 11.25. Therefore, this is just going to be equal to BA times the rise, which in our case here is 3 divided by root of 11.25. And this one is BA times the run, which is just 1.5 divided by root of 11.25. And then we have this one here, which is BC, and this is just the same also, it's just 1.5 root of 11.25. And then we have BC. We have BC there. Let me take it this side. BC, which is just equal to 3 divided by root of 11.25. Great. So what do we have? So we say summation of forces. We start with the first case. Let's call this case as case 3-20. 3-20. So we say summation of forces in the x equal to 0. Because of symmetry, we are saying symmetry is going to be in the vertical direction. So in the x we have BA. BA, let me just do the multiplication in advance. So 1.5 divided by root of 11.25 BA plus 1.5 divided by 11.25 BC minus F equal to 0. Okay. Because of symmetry, we know that BA is equal to BC, which we are just going to call equal to Fs. Therefore, this just becomes 2 by 1.5 divided by root of 11.25 Fs minus F. What is our F? This is what we are looking for. F equal to 0. Okay, great. So there we go. Just move that. So then we know that Fs is just equal to K times S, and K is equal to what is our spring constant? It's 500 Newton per meters, and S is just equal to L final minus L original. Okay, and we know that L final, let me just move this somewhere there like so. I think we can leave it. Okay, we know that L final, L original is just equal to 3 meters, and then L final, we know it already, is just equal to square root. We've already found it is root of 11 11.25. So which we found is just 1.5 squared plus 3 squared, and this gives us root of 11.25. So with this information, we can therefore plug everything in. So we can say we have a 3 divided by root of 11.25, okay, times s. S, we are saying this is a 500 times L final, which is just root of times L final, which is just root of 11.25 minus 3, and then minus f equal to 0. And therefore our f is just going to be equal to we have root of 11.25 minus 3 times 500 times 3 divided by root of 11.25. So we have 158.36 newtons, right? So root of 11.25 minus 3 times 500 times 3 divided by root of 11.25, 158.36. Great. Let's go to case number 2. Case number 2, which is case 3-21. 3-21. So the equation that we are going to use, we use this equation here. This part, we're going to use this equation here. This equation here. Okay. So we know that this part is d, so we just write it as d. So we'll have 2d divided by root of this is the hypotenuse. This is the root of, this is again the length. This root of 11.25, we don't know it, so we just write it here as d squared plus 3. Remember what it is, this one? Okay. We don't know what it is, so it's just d, where we have 1.5, just d. Then fs has a k, which is a 500 even in this case. Let's write down. So we know that our k here is 500 Newton meters for the second case, and f is just equal to 175 newtons, and of course L original is 3 meters. So we have a 500 here. What else? By root of L final, which is just d squared plus 3 squared minus 3 and minus f, seeing this f there, minus 175, okay, is equal to 0. So like I said, we are using this equation here. Okay, all right, so we can write this. So looking at this, for me, I'm just going to use the trial and error method to solve it, but we can solve it with whichever method. Okay, so I'll use the trial and error method. All right, what has happened? All right, sorry. So I'll use the trial and error method. So for the trial and error method, we are saying we are on a number line like this. We'll have negative this side, positive this side, and we'll write this as a function of d. And we know to say we're going to have one value of d that will give us a negative. We'll have another value of d that will give us a positive, and somewhere in between, that's where the solution lies. Okay. All right. There we go. So let's say this is a function of d, which is just equal to 2d divided by root of d squared plus 3 squared by 500 times d plus 3 squared minus 3 and then minus 175 equal to 0. Alright, so let's draw our table as usual. Draw a table, and then we need the range, the interval. So the interval for d, so d will be from 0 meters to I'll compare the value of f. In the first case, the value of f we found 158 and d was 1.5. Here we've been given 175, so I can go for d equal to 3. If it becomes small, I can keep on increasing it. Okay, the idea is based on this function. Okay, you want it to be closer to 0. That's the idea. So if none of the values from 0 to 3 makes this particular function work, then I can increase 3 to a higher value. Okay, so we have d there, we have f of d like so. So when d is equal to 0, this part is all 0, we'll have just a 175. When d is equal to 1, let's plug in. What do we have? That's a 2 divided by we have a 2 divided by root of, that's 1 plus 3 squared, that's 10, root of 10 times 500 times root of 10 minus 3, okay, then minus 175. So we still have a negative 123. So let's make it 2. So 2, it becomes 4. So 2 square 4 plus 9, that's 13, root of 13 times 500 times root of 13 minus 3 and then minus 175. So it becomes a positive 160. So we know that in between 1 and 2, this is where the solution lies. So we start iterating. So we start iterating between 1 and 2. So we get the average of 1 and 2. 1 plus 2 is 3. 3 divided by 2 is 1.5. We plug it in. 1.5 plus 3 squared, that's 11.25. Okay, so we have a 3 on top, root of 11.25, okay, times 500 times root of 11.25 minus 3 and then minus 175. So it becomes a negative 16.6. So we can get again the 2, again average of the 2, that's 2 plus 1.5 divided by 2. So this becomes a 1.75. So we plug it in, 1.75 squared plus 3 squared. This is a 12.0625. So 2 by 1.75, okay, divided by root of 12.0625 times 500 times root of 12.0625 minus 3 and then minus 175. So this becomes a 63, a positive value. Okay, so again we get values that are smaller, right? Negative, smaller, negative, small negative value, small positive value. So 1.5, again we get the average plus 1.75. Average of that, we have a 1.63. Okay, So 1.63 squared plus 3 squared, so 11.65 or just 11.66. So 11.66. Okay. So 2 by 1.63 divided by root of 11.66 times 500 times 11.66 minus 3 minus 175. So this we get a 22.9. Alright, so again we can iterate between the two. 1.63 plus 1.5 1.5 plus 1.63, average of the two divided by 2. So let's say we have a 1.57. 1.57 squared plus 3 squared. Okay, 11.46. Okay, 11.47. 11.47. Okay, root of 11.47 times 500 times 11.47 minus 3 minus 175. So slowly it is reducing, but it is reducing so slow. So we can get another one there. Another, let's draw another table there. Okay, so we have theta, we have D, not theta. You know, when you are used to theta every time, we have D. So we need to get an average of the two. 1.5 plus 1.57 divided by 2, we have a 1.54. So 1.54 squared plus 3 squared is 11.37. Okay, 11.37. 1.54 divided by 11.37 times 500 times 11 point root of 11.37 minus 3 and then minus 175. So we have a negative 5.13. Okay, we can get the average of the two, 1.57 and 1.4. Just 1 minute. Okay, so 1.57 plus 1.4, average of that we have a 1.56. Okay, 1.56 plus 3 squared, that's 11.43. 11.43. So 2 times 11.43. 2 times 1.56 divided by 11.43 times 500 times root of 11.43 minus 3 minus 175. Okay, so we have a 0.72. Not bad. So 1.54 plus 1.56, we need to get an average again of the two, the smallest values, then divided by 2. So we have 1.55. Let's try this one. 1.55 plus 3 squared, that's 11.40. 11.40 root of 11.40 times 500 times root of 11.40 minus 3 minus 175. So minus 2.21. So I think we'll do the last iteration. 1.56 plus 1.55 divided by 2 comes back to that. So we'll go for this one. We'll say D. Therefore, when you do the iteration, it is still giving us 1.56. So we can end here. we'll go for this one. Okay, that's the one that has the lowest error. So D approximately is just equal to D is equal to 1.56 meters. Okay, so this is really about it. We found the force, which is here. Okay, and then in the second case we found the value of D. All right, I hope the video was helpful. I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.